More parts about polynomial functions is covered in section 4.8. So far, you have these terms of polynomials, and notice that a zero, a solution, and an x-intercept to me all basically mean the same thing. They're the points at which the graph crosses the x-axis. The other situation is you can have a factor. A factor is part of a polynomial. So that's often seen as x minus k, and this would be k0. So that's a little bit of a review. Getting into new stuff, we have turning points. And a turning point is where in a graph, you may have something like this. That's a turning point, and that's a turning point. Why? If you look at the slopes. Positive slope, negative slope, positive slope. It's where the slope goes from positive, negative, or negative, positive. And what this is saying is that a polynomial has at most n minus 1 turning points. So if you have p of x equals 3x to the fourth plus something, that's the degree, that's what your n is. So at most, it had a maximum of n minus 1, or 3, right, because that's 4 minus 1, 3 turning points. And so it's always going to be n minus 1. Moving along, that's all I wanted to do with turning points. Let's go to something a little bit more interesting, which is even and odd functions, which carries forward. And you have to know these definitions on even and odd. This is the definition for an even function, and this is the definition for an odd function. Notice that both of them have f of negative x. That's where you want to start when you find out if it's even or odd. So this is an even function. Notice that it's symmetric about the y-axis. This, and if you put in a negative x, you get the same y as a positive x. This is symmetric about the origin. If you put in negative x, you get negative y. Also, you can get this by rotating it at 180 degrees. Different way to think about it. Doing a couple problems. We're always going to start, again, with the f of negative x. So in all of these problems, I'm going to first figure out what that is. If I put negative x in for x, I get negative x cubed plus 7x. Now, these are not the same, so it is not even. Therefore, what I have to do is find out what negative f of x is, and that's a negative of my f of x. And so that's going to really be equal to a negative x cubed plus 7x, which is the same thing as that one. So my negative f of x is equal to f of negative x. That means that this is going to be odd. These two right here are equal. By definition, it means it is odd. Let's see what g of negative x is. Putting in the negative x, you get this. And therefore, g of x equals g of negative x, and that tells me that this is even. And the last one, h of negative x, putting in a negative x, gets you this. These are not equal, so it is not even. So you have to try the h of x, negative times negative 1. That becomes negative x cubed minus 2. None of these are equal, so that is going to be a neither. So it could be even, it could be odd, it could be neither. It all depends upon the definitions. And again, this is tricky. The way to understand it is to make sure that you get these definitions and know them so you can understand if it's even or odd or neither.